Norway has a long tradition for wooden constructions, mostly smaller buildings. Like other countries in Europe, most of the existing building mass is energy inefficient, while our new buildings are nearly at passive house level. Increased rate of energy efficient deep renovation is an important focus area. The Norwegian demo building owner, with more than 11,000 rental units, has a lack of maintenance of their buildings. At the same time, they have ambitious environmental goals. Cost and energy efficient solutions have a large potential to improve their building mass and are highly appreciated. The case study is a 2-floor apartment building from 1971 for social housing, and a robust solutions are needed. It is a small wooden building with in total 8 apartments of approximately 40 square meters each. Before renovation, it was a drafty building with annual energy use of approximately 250 kilowatt-hour per square meter year. Deep renovation from outside by use of prefabricated elements, a goal of 60% energy reduction, and low tenant disturbance was ordered. Within weeks, it was turned into an energy-efficient building with energy production. How was this possible? The scientific advisor and the building owner had a good and close collaboration from start. A design team was assigned to the building owner, hand-picked based on knowledge and collaborative ability. To ensure suitable design of the elements, skilled manufacturer was contracted early in the design phase and throughout the process. We think this was crucial both for production, transportation and mounting of the elements and their integrated technologies. Good relationship, close collaboration and discussions between the scientific advisors, design team, manufacturer and the building owner were essential aspects for a fruitful result in the limited time frame. The renovation concept depends on the existing building and relevant climate. The 4R in EU project develops the recommended renovation packages, and the Norwegian demo case represents a suitable renovation package for cold climates. New energy-efficient buildings in Norway are compact, well-insulated, airtight, and use balanced ventilation with highly efficient heat recovery. These are also the goals for the deep renovation. However, deep renovation can be challenging. The existing shape and compactness are hard to change. An extra floor was considered, but not possible for height restrictions. The new elements and existing construction together aim to give a new value as required for passive houses, but the existing slab on ground was hard to compensate. Airtightness is controlled by the new construction. We also had several discussions for what regulations and policies to fulfill, for instance for fire, since there are no specific building codes for renovation in Norway. Use of renewable energy could be water-based system or electrical ones. PV panels was the natural choice since the existing heating and hot water solution was based on electricity. Prefabricated elements with integrated technology was the chosen concept for the walls and should be attached to the existing building. But renovation projects can give surprises. Early investigations exposed lack of load carrying capacity. New elements were therefore mounted on new insulated sole foundation. This solution also improved the slab on ground floor that could only be insulated on the edges. Prefabricated elements were also chosen for the roof. This was a quick and easy way to add extra insulation as well as closing the opening between the new elements and the existing roof. The 4R in EU early reno tool was used for investigating cost-benefit options for PV production, while local constraints were vital for actual number and placing. Solar cells were integrated in the south facade, pre-installed in the factory, not at the construction site as in many other projects. This required extra precautions for transport and mounting. Improved indoor air quality is important when upgrading in cold climates, as cold draft or closed inlet openings often is a problem. Balanced ventilation with heat recovery is the recommended solution. However, space for the air handling unit and supply ducts is often lacking. Prefabricated technical room and shafts are here added as separate elements on the north facade, also allowing space for the supporting equipment for PV production. New supply air ducts are integrated in the north facade from the air handling unit to the bedroom. Then you just need to get new ducts to fit to old air openings. Details and tolerances. Details and tolerances. Norway is in world class of using both BIM and wooden constructions. BIM is often used for scan and design BIM. Here it is further used for element design and production, as well as optimizing of building materials to reduce waste. Despite being a research project, the solution should aim at being market acceptable. This involves focus on cost-efficient production process when optimizing energy performance, as well as including market acceptable products for the technical integration. It should also be noticed that few manufacturers have sufficient expertise and a production line suitable for advanced elements with integrated technology. Risk management has been an important success factor in the project. Identifying risks and planning for the unexpected is crucial. Use of prefabricated elements means early decision-making process for the building owner. This implicates early mapping of existing situation, decision on renovation concept and ordering of materials as well as integrated technology. Existing construction must early be controlled for moisture problems, asbestos or other hazardous materials. Also mapping of existing cables, pipes, antennas, etc. is important to avoid delays or problems. Probably the most thrilling aspect using prefabricated elements together with existing constructions has been the tolerances. Even though the building has been 3D scanned, modeled and produced with strict tolerances, we must admit that controls also were done with the yardstick on the most critical details. Prefabricated elements can be safely produced. The real challenge are the joints between each elements and the existing construction to achieve desired result. Moisture protection and airtightness are secured through the new elements, and we should preferably not add any new problems between the new and existing construction. This is no trivial task, and skilled experts have been used as advisors, and this is really important. Safety in transport and mounting is of great importance. In this project, a 1.5-ton element is lifted in a narrow building site, turned around in the air and put in place with a full press corps present. All reasons to be proud. The actual mounting of the elements took just over 2 weeks, and most of the work could be done from the outside. Rain protection was planned if necessary. Old windows were removed as new elements were mounted, this to maintain escape routes by the end of the day. The tenants could stay and were very little disturbed. The Norwegian case study is a success story. But even with strict focus on high energy performance, it can be hard to reach a plus energy building or energy label A in Norway. Factors like existing shape and slab on ground floor cannot easily be changed, and we need realistic expectations. The goal of 60% reduction of energy use is reached, but at the energy label level B according to Norwegian aspects, only a few kilowatt hours from reaching label A. Airtightness is another important focus area already at the design stage. Of course, in all joints between elements must be in focus, but also plan thoroughly for all penetrations with pipes and ducts that preferably should be prefabricated as well. Avoid difficult junctions and corners and focus also on airtightness between new and existing constructions below ground level. Airtightness is kept by the new construction and must be in focus also through operation and maintenance.